Hey everyone, in this video we're going to talk about linear equations, and let's write down an example of one we're going to solve. So let's write it down, 5 times x minus 3 in parentheses equals 2x plus 9. Now, before we begin solving it, we have to realize what our goal is. So our goal is to isolate the variable. And what is the variable in this case? Well, it's x, the letter in this equation. And there's also another x on the right side of the equal sign. So we have two x's, and our goal at the very bottom of this, we want to get x equal to some number. That is our goal. That's how we solve for x. So in order to do that, we have to get x by itself and isolate it on one side of the equal sign. So that's what we're trying to do. And before we begin solving this and begin isolating x, another important concept in mathematics, I'll write it down here, are terms. Terms. So a term is any grouping of numbers that can be written in this way: a times x to the power of n, where a and n are numbers or constants. They're constant numbers, so they can be any number at all. And x is a variable. X is a variable. So again, a and n are numbers, and x is a variable. So this entire thing, a times x to the n, is one term, and that's really important. So let me erase these, and let's try to identify the terms in this equation. So let's try to look for terms. We have, outside of these parentheses, we have a 5 right here, times this entire thing. So you could actually say that this entire thing is a term since it's 5 times something. And then within it, within the parentheses, you actually have two separate terms. You have x, and then you have -3. So x and -3 are separate terms. So it's very important to understand terms. Let me make it clear. Terms are separated by plus and minus signs. So plus and minus signs, addition and subtraction, separate terms. So now that we know that, the right side, we can identify two terms right here. We can identify right here 2 times x, 2x, is one term, and +9 is another term. So we've identified all our terms, and that'll be useful for solving this particular equation. So let's go ahead and begin solving this. There are a few ways we can do this, but one thing you might notice here is that we have 5 outside of the parentheses. And if you've seen my video on the properties of numbers, then you might recognize the distributive property. So we can actually distribute this 5 to each term. So 5 times x and 5 times -3. So what's 5 times x? That is just simply 5x. 5 times x is 5x. And what's 5 times -3? That is -15. Okay, and let's bring the rest down. Let's bring everything else down to x plus 9. Perfect. So we have this now, 5x minus 15 equals 2x plus 9. Now, we're trying to isolate x. We're trying to get it by itself. So maybe we start with this x on the left. let's try to get this x by itself. So it has this 5 attached to it, but we will deal with that later. We can get rid of this 15 first, this negative 15. So what's the opposite of negative 15? That is positive 15. And positive 15 over here. And we have, let's write everything else down. 5x equals 2x plus 9 plus 15. And we can evaluate this 9 plus 15 right here, positive 9 and positive 15. But let's hold off on evaluating this because I want to show you something at the end. So the next thing we should do is let's group this positive 2 and let's put it on the left side of the equal sign with this 5x. So because I want both terms that have an x to be on the same side of the equal sign, so essentially I want to move this here. Let's go ahead and do that. So how do we do that? Well, we can subtract 2x from both sides. So minus 2x, minus 2x. And right here, we have 5x minus 2x equals, and everything else, positive 9, which we could just write as 9, and positive 15. 9 plus 15. Excellent. So now we have 5x minus 2x on the left side, and 9 plus 15 on the right side. Now let's identify our terms again. What are our terms? So we have 5x right here, positive 5x. We have negative 2x, positive 9, and positive 15. So what's important is that 5x and negative 2x are like terms. They are like terms. So what makes them like terms? It's because their variables have the same exponent. So they both have a variable x, and they both have an exponent of 1. You don't see it, but it's implied. Whenever there's a number to the power of 1 is just the same number. So technically every number has an exponent of 1. But they're both like terms, because this is 5x, this is negative 2x. And alternatively, just as a quick example, if I had 5x and negative 2x to the power of 2, these are not like terms. Why? Because this one has an exponent of 2, while this one's exponent is 1. So they're not like terms. And then similarly on the right side of the equal sign right here, the positive 9 and the positive 15, 9 plus 15, they're both like terms. They don't have a variable at all. They're just numbers. Therefore, they're like terms. And the reason why like terms are important is because they can be combined. So how do we combine these like terms? 5x minus 2x? Well, let's not think about the variable for a second. Ignore the x. What is 5 minus 2? 5 minus 2 is 3. And then we attach the variable x. So 5x minus 2x is 3x. And just a quick mini example, if we had 5x squared minus 2x squared, that is 3x squared. It's just 5 minus 2. And then you grab the x squared and you attach it to the result. So 3x squared. Just as a quick example of how like terms can be combined. So we have 3x equals, and right here, positive 9, positive 15. We combine them. 9 plus 15 is 24. And there we go. We're very close to isolating this x. Because we combine these like terms, we had x's in 2 places, here and here. Now we have an x in 1 spot, right here. And it becomes very easy to solve for x now, because all we have to do is we notice we're multiplying by 3. This is 3 times. So what's the opposite of multiplying by 3? That's dividing by 3, which we'll do on both sides. And we are left with x equals 24 divided by 3, which is 8. And that is our final answer. So the answer to this entire equation is x equals 8, to this original equation we had up here. And we did it by isolating the x and grouping and combining like terms. So I hope this video helps, and please let me know if you have any questions in the comments below. Thank you for watching.